Namaskar, ladies and gentlemen. Welcome to our first session of day 2. Before we commence this session, I would like to announce a very sad condolence message with you. With a very heavy heart and deepest regret, we inform you that our great esteemed leader and co-founder, Mr. Bhupi, met with a tragic accident last night and breathed his last. He was an inspiration and voice of VVTN. We must continue his great legacy and be strong by fulfilling the vision he so lovingly built in taking VVTN family forward towards our unified goal. In his memory, we announce that today is a non-operational day at all VVTN offices. May he rest in peace. With this, I conclude the sad news. Ladies and gentlemen, we have had a fruitful round of deliberations yesterday for all the sessions. We look forward to the same today. Today's first session is on making India a global center for electronics hardware system, design, and the launch of MAIT's championing 1,000 electronics hardware startups. India's engineering and design prowess is acknowledged globally. First services capabilities are celebrated and provided India leadership position, the electronic hardware design service of India becoming a favored destination for hardware manufacturing, the design function is a collateral outcome. The large pool of engineers available across the country and well-established engineering segments offer investors plenty of choices for hardware design investment. As India looks to strengthen its hardware industry, the electronic hardware system R&D will play a vital and complementing role in maximizing the India value addition through design-led manufacturing and making it a perfect choice for global investors. Government officials, scientists, and industry leaders will deliberate and set the vision for India to become the global hub for the electronic hardware system design. Ladies and gentlemen, let us now commence the session. I would like to firstly welcome our esteemed chief guest, Dr. V.K. Saraswat, member Niti Aayog. A very warm welcome to him. I think he's trying to log in, or he has logged in. We welcome Dr. Sudhir Kamath, Director General DRDO, Mr. Rajiv Khushru, Chairman of the Board of Directors from IESA, Mr. Suhas Mansingh, VP Engineering, Cisco, Mr. Murali Krishnan B, CEO, Xiaomi, Mr. P.S. Ishwaran, Senior Partner, Deloitte, and Mr. Harish Krishnan, Vice President, MAIT and Managing Director, Public Affairs and Strategic Engagement from Cisco. With these words, we would like to now commence the session. May I firstly request Mr. Harish Krishnan to kindly make his welcome address.
Harish, you are on mute.
Yes. Hey, thank you very much. Rajiv, there's some noise coming from your end. So if you could mute yourself, it'll be good. First of all, I want to start by joining in condoling the passing away of Bhupi. He was a great leader. I just had the good fortune of knowing him for the last couple of months. He was a very inspiring and passionate leader. I remember him passionately talking about manufacturing in India, telecom products, and he was saying very famously that while you'll not be able to go to the borders and fight in a physical battle, but he'll make in India and make India strong. So he would ask me to come to his factory in Manesar last week, and that didn't happen. But I really feel extremely sad at his passing away, and all our thoughts are with his family. With those words, I would like to welcome all of you to the second day of the Electronic Manufacturing Summit. As we heard, we had a fantastic first day of participation. Adversity always brings the best at some times. So like we talked about yesterday, we were deliberating whether we should postpone this event or go with it. We decided to go with it and show the resiliency of our supply chain, so to speak, and have the event. But yesterday's session was the best that MAIT had ever done in terms of participation of government leaders, industry leaders from not only India, but from outside India. It was like a very good interactive session that we had. So we start day 2 today, and today's session is Baking in India, a global center for electronics hardware system design, and the launch of MAIT's championing 1,000 electronics hardware startups. It is my great honor to welcome Dr. V.K. Saraswat, member of Niti Aayog, an Indian scientist who served in numerous roles in defense administration in India. Thank you, Mr. Saraswat, for joining us today in this crucial discussion. We would be very honored to hear your views as we move along the program. It's also my honor to invite Dr. Sudhir Kamath, an outstanding scientist who is the Director General of Microelectronic Devices and Computational Systems and Cyber Systems, DRDO. Your exceptional experience in electronics and telecom products will be pivotal as we move towards implementing India's robust strategy for becoming a global hub for electronic hardware design. I'd like to also welcome and congratulate Rajiv Kushu, who just became the chairman of the Indian Electronic Semiconductor Association, ISA, who's also our partner with MAIT. While there's been a lot of focus on bringing manufacturing to India in the last few years, in MAIT, we thought it was important to lay equal emphasis on design. Design, as we all know, perhaps brings more value than even manufacturing does. And the good news is that India already has a robust design industry. Apart from Indian companies, there are several global companies who have set up their design shops in India. And almost 90% of India's design is now exports. While this is good, there is a huge amount of potential for designing for domestic needs, especially with the proliferation of connectivity, of IoT devices, of portability. I think there is a huge scope for designing in India for some of the challenges that we have in agriculture, and health, education, drinking water, and so on and so forth. So I think there's a huge amount of potential. With this in mind, we partnered with Deloitte, and we organized a series of roundtables in the last few months. We invited participants from Indian industry, global companies, young startups, government leaders. The idea was to really take stock of where we are as a country in design and where we need to be, where we can be in by 2025, identify the bottlenecks, and then to also give some high-level solutions to overcome that. The result is a report that will be unveiled later in this session. I do not want to take away the thunder from Deloitte, therefore I will not be going into the details of the report. It's sufficient to say that we've set up a very ambitious plan or target of 100 billion design industry from India by the year 2025. Dr. Saraswat, welcome. Very good to see you, sir. The report provides a very high-level recommendation of how to get to this ambitious target. I want to really call out Ishwaran, partner in Deloitte, for great work that he's done, and not only bringing out the report, but also in organizing these workshops very diligently. Thank you, Ishwaran. Design-led manufacturing also provides scope for young entrepreneurs to bloom, create startups. So another initiative that MAIT is very excited about is this 1,000 hardware startups initiative that we'll be launching today, and my colleague Murli will speak in more details about that. I'm confident that today's deliberation will prove pivotal in to India's electronics hardware design and becoming a sunshine sector in the days to come. With these opening comments, I turn it back to you.
Thank you, Mr. Harish Krishnan, for your extremely warm welcome address and for setting the context for this session. I would like to next request Mr. P.S. Iswaran, Senior Partner Deloitte, requesting him to kindly present the knowledge paper.
Thank you, and thank you, Harish, for the kind words. I think before I sort of the next 4 to 5 minutes talk about the paper in context itself, I think over the last 3 months, and to everybody in the audience, I think over the last 3 months we worked together with MAIT, and Harish, thanks for your great support too. I think we worked with MAIT to really have sessions which are cross-pollination of ideas covering multinational companies, Indian companies, startup ecosystems, and our leadership from the government. And the intent was to really go and not just have a scrape of the periphery, but really start understanding what are the nuanced aspects that we may have to deal with, and what are those things which can really be strengths that can be completely leveraged. So we had one in Jan and one in March, and I'm happy to say that it also gave us a fair degree of insights in terms of what people are expecting, both sides, be it on the side of organizations, be it on the side of the industry associations both together, or what the government also expects from organizations as they move forward. So with these in context, we also started looking at where the market was heading and what are the big opportunities for us. And I don't know whether there is a slide. I actually had a slide share, so maybe I can share that on behalf, or I don't know whether Sandeep, you're sharing it, but I can start with the share. Yeah, is it visible now?
And it is say starting to share content. So as soon as you do it, it will come. Yeah, you can see it.
Yeah. Yeah. So if you really look at it, I think, as Harish rightly mentioned, I think our intent was to really understand what our potential is and where we could land up. And essentially, we think there is a strong aspiration for us to achieve a 100 billion target as a hardware design hub in India. All the fundamentals, according to us, are in place. And I think there are some actions that would enable across all stakeholder groups that would enable this. So just to give you a perspective, right? Our ESDM market itself is pretty large right now, estimated to be about 220 billion, which obviously includes a fair bit of manufacturing. And if I take hardware, electronic design itself, we are talking about on a nominal path, really reaching about $60 billion at a CAGR of about 20%, which essentially means that with all the Make in India program that we have on one side, with the industry 4.0 revolution that we have, which also helps us with the total factor of productivity enhancement in India, and with all the enablers that are there, we are producing about 200 chip designs every year. We have at least about 20 or 1,000 on a minimum. When I started talking to all the companies, I think the number substantially exceeded 20,000, but at least a minimum of 20,000 if the data is to go by. Embedded systems being the largest with about 85% of share of the design services segment.
Ishwar, I just don't
make use of the fundamental foundations to move forward. And
Ishwar, to interrupt you, like Rajiv, there's a lot of noise coming from your system again. If you could please mute yourself. Thank you.
Yeah, is it okay now? Harish? Is it okay now? Harish, can I speak now?
Go ahead.
Yeah. So I think the fundamental focus that we went with was to say, how are we placed on the foundational elements? Is there a big platform for us to grow? And are there some of the key elements around talent, the key elements around innovation, key elements around exposure to global markets, and fundamentally around some of the core and technical elements in place? And you would notice that in all the four factors that I spoke about, we have the foundational elements in place. Therefore, with that in context, we also analyzed as to where the market was moving. We spoke to a lot of the end-use segment companies, and one of the biggest things that we heard was that most companies wanted to really overcome the disadvantages of total factor productivity by really looking at Industry 4.0 as a revolution. And if they were looking at it as a revolution, a lot of it they were thinking as to how indigenously we can build up a lot of ecosystem around 4.0, which includes right from hardware design, then into manufacturing. So we said, can we start thinking about what would be our aspiration for a design-led manufacturing model? And you really start thinking about it, 100 billion aspiration seems very, very logical for us to start thinking about. Anyway, nominally, you're looking at about 60 odd billion. The next 40 billion is a stretch that we would need to have with a lot of focus. So we said, let's start thinking about what would be those focus areas that we all may need to really look at. And we doubled down on about 12, 13 areas in the report, but I would talk about some of the 7 or 8 which are the most relevant for us. Not run through each one of them and make it difficult for you, but primarily, focus on strategic segments has been the most important ask. I think segments of import dependency and segments critical to the growth of the economy, where we can also link them back to Atmanirbhar, potential point number one. Second one, very similar to PLI, grand success. We have had some phenomenal investments in PLI. Can we actually move it upstream into a design-linked PLI model? Encourage hardware electronics value addition. So just like how we have domestic value addition in PLI, can we think of design value addition in India and have them specifically linked to investments for design and development? Third, obviously, focus on specific sectors. PLI has been extremely successful. We had 15 champion sectors. We're extremely focused there, and we are saying this is where we will get long-term competitive advantage. Very similarly here, can we focus on crucial sectors? And with those crucial sectors in perspective, we focused on about 5, given the strategic importance as well as the national importance: electronics, hardware, telecom, military, and consequent 0 rating of design services, so that people are really able to take advantage of it. The fourth one is really shared infrastructure. One of the things that we noticed is that there is a heavy dependency into the ecosystem of medium enterprises, small enterprises, and also some level of startups. And many of the areas like prototyping and testing, one of the fundamental issues that we have is these are high cost operations and very clearly not in the realms of smaller companies. And therefore, a need for us to create the shared ecosystem model, which can also act as facilitation centers. We can decide as to how we will place them where, but this would really be driving up both utilization as well as mentorship models, which has been very successful in other parts of the world. Taiwan is a classic example of that. We have sort of created some examples in the report. The fifth one is really what we thought is, when we looked at IMEC in Belgium, and there are about 4,000 engineers, the biggest surprise is that a lot of them are Indians, which essentially means that, they're focusing on one area of development, predominantly semiconductors, but really most of them being Indians. Can we create a nodal body on the lines of IMEC, which will focus on specific areas linked to the point numbers 1 as well as point number 3? And therefore, with those in context, how can we really have those engineers really focusing on this? The sixth one was around incentivizing indigenous hardware designs. Now, as we spoke about Industry 4.0, one of the things that the PLI has been extremely instrumental is in creating the Make in India model and therefore encouraging domestic value addition. Very similarly, can we have models which will enable the incentivization and adoption of industry, especially in Industry 4.0 situations? And in context, how can we recognize electronics hardware as a champion sector? And with the champion sector would follow a number of the initiatives that the government would have going forward into the future. So it will become a self-sustaining mechanism that we can think about. And without that in perspective, I think today, Harish, you spoke about the 1,000 startup model. But really, one of our suggestions was, can we create an enabling ecosystem for startups, which would mean that startups can incubate themselves on an ongoing basis. And with dimensions like shared infrastructure, people can actually grow themselves in the marketplace. So primarily, if you look at it, it's a combination of about 4 things. One is really a set of actions from the organizations, including talent development, and therefore really looking at segments of focus. Second is really a set of actions from the government, including enabling the Make in India models. The third one is really around how can we really generate the startups and the startup models. And finally, really looking at how we can really generate the equivalent of the Make in India or the indigenous hardware design models, and that can be incentivized through the life cycle. So in summary, I think these are the big areas that we wanted to really focus on. We also had a set of collateral suggestions, about 5, 6 of them. So a 16-point agenda is what we would recommend as we start thinking about really looking at 100 billion hardware design in India. So Harish, thank you so much for the time, and maybe we can debate on some of these things later.
Thank you.
So I'll stop sharing. Thank you.
Saniti, can you go ahead?
Yeah, I just announced. I would request our next speaker, Mr. Rajiv Khushu, Chairman Board of Directors, IESA, to kindly deliver his industry address.
Thank you everyone for the opportunity. Keep my video off for so that I have full clarity from the audio part of it. And to start with, I would like to take this platform to control the death of people who is IEC chairman.
You're able to get your voice well. There's some broadband issue.
It's not audible.
Okay.
So can we probably come to you later, Sanati? Let's connect it and then we can come to you.
So shall we move on to?
Yeah, we move next speaker. We'll come back, Rajiv. Yeah.
Okay, all right. So we will get back to that address probably after the sort of audio works out. Meanwhile, may I request Mr. Murali Krishnan B, CEO of Xiaomi, to kindly take us through MAIT's program to champion 1,000 hardware startups.
Murali, you're on mute.
Sorry about that. Hi, thank you and good afternoon, everybody. And if Sandeep is online, Sandeep, I request your help in flashing my deck. I'm having some challenges on that front. Never mind. Since that's taking time.
Rishi is doing it, sir.
Okay, great. Thank you, Rishi. You can just put that on slideshow. We can get started. Good afternoon, everybody. Thank you so much. Truly my privilege to have this opportunity to talk about what can we do together to champion hardware startups in India and create a conducive ecosystem for 1,000 or perhaps more to flower. The way, if you were to reflect on the past few decades of information technology and the revolution in India, many successful companies have been built on providing IT services to companies in India and across the globe. They've scaled up to become amongst the best in that industry, scaled up from just focusing on services to actually building out products today. But if one were to soothsay and figure out where all of this should head in the future, then one can place a bet on hardware electronics being the next big opportunity for us to pursue. And why would you say that? Because at this point of time, there is a unique intersection. They're actually at the cusp of a multitude of opportunities, most of that facilitated by the government of India's initiative to pursue an Atmanirbhar Bharat, to pursue electronics manufacturing in India, to make India a hub where you could design for India and make for the world. Now, this is not the first time that one is talking about hardware startups in India. It's been spoken about enough number of times in the past, and we will continue talking about it in the future. And fortunately, India already has quite a few of those startups pursuing the growth stage, be it Grey Orange in robotics, be it Boat in consumer electronics and audio products, be it Aether in electric vehicles, Goki in wearables, Atomberg in smart fans and other home appliances, biotech, medtech, agri-tech, robotics. I mean, there are multiple companies across the entire spectrum built out of India. However, the reality, and all of us realize that, is that we have a long way to go. If you just look at the tech electronics startup ecosystem across the world, US leads with over 300 unicorns with the likes of Magic Leap, Peloton, Fitbit, Locus, etc. China coming in number 2 with Xiaomi, which is a company that I represent. And then you have DJI, Ninebot, and so on. And of course, you have Israel, which is the hotbed of innovation with multiple sectors being explored across autonomous vehicles, vehicle-to-vehicle communication, healthcare, drone, robotics, biotech, agri-tech, the entire spectrum. And the other way to look at this is of all the patents filed across the globe, India has less than 1% contribution, actually about 0.77% is the number that I read in the report, are actually patents filed from India. Now, all of this is not doom and gloom, right? There is definitely an opportunity to be pursued here if you can get down to the brass tacks, understand where the problem is, and figure out if we together can solve for it. And Rishi, if you can go to the next slide, please. So the way we should think about this is look at 3 different dimensions, look at 3 different parameters. The first is just the foundation, which is education. It's a little bit unfortunate that the quality of environment that we have, especially in engineering education in India, is perhaps not the most inspiring. I don't mean be disrespectful, but it is a reality that all of us know. There is a lack of adequate infrastructure at the formative stage, and perhaps not the right conducive environment to foster creativity and innovation. And the less said about building a strong STEM foundation in schools, the better. And it's also a little bit funny that smart engineers graduating out of India's best engineering schools probably find it more easier or attractive to go start up in the e-commerce space or the services space or build out an app instead of thinking of building a hardware product for India and the world. The problem is not talent. Talent always exists. Perhaps the problem is figuring out what the right environment and platform to nurture and grow that is, which brings me to that second point, and that's one of infrastructure. And this again is a multi-dimensional problem, be it tool rooms, be it test labs, be it the ability to prototype in a rapid manner, testing approvals, all of these are areas for improvement. And perhaps a coordinated strategy can help overcome some of the obstacles that a lot of startups face in this area today. And the other big problem statement is actually bridging that gap between prototyping and mass manufacturing. Do we have the right conducive ecosystem of ODMs in India to take that forward? Is something that, of course, government policy is trying to address, but it is today a constraint that perhaps limits hardware startups in India. And the third element is one of policy. And all credit to the government. The government's thinking is obviously in the right direction. With Digital India, Startup in India, Make in India, we're all thinking about the right thing and laying out the right policy framework. But one needs to realize that, look, starting up a hardware startup is not like making an app. It requires significantly higher funding. The entire trial and error process is significantly longer. The gestation process is significantly longer. And once you have prototyped, actually taking something to mass market takes even longer. And therefore, you need to create a conducive environment for investors to be interested in this space. And then, of course, you need stable policies that perhaps encourage sourcing from local hardware startups, maybe tax incentives for large corporates to support this hardware ecosystem, and perhaps that can encourage more people to start looking at this space. And many large corporates in India are actually thinking of this from that perspective. We should have perhaps a stronger framework to encourage domestic IP creation and the ability to monetize that. Given all of these perspectives, what is it that we at MAIT want to do? And Rishi, to the last slide, please. At MAIT, over the past so many months, we've been the previous slide. We've been thinking about what is it that we can do to actually champion and foster an ecosystem for hardware startups in India. And we took up this lofty goal, this very exciting goal of figuring out how to champion 1,000 hardware startups in India. Now, the question is like, why now and why MAIT? Why now is an interesting question. And the answer to that is, at this point of time, we actually sense a magical window of opportunity where the policy framework is aligned to encourage designing in India. We just saw that in the address by Mr. Ishwaran, and making for the world. The investment community will follow with the government policy completely aligned in this direction. And as to why MAIT? Well, the answer is actually quite simple. MAIT has the best representation from the corporates operating in India, not just based in India, but some of the best companies across the world focused on the ICT industry. Number one, if you can take all the expertise they bring together, figure out a conducive environment where you can bring academia, the government, policies, corporates, investors, accelerators, incubators, and figure out startups who have figured out their prototype, right? The point is you should be very clear on what kind of startups you want to work with in this situation. So if there are startups who've got their early product in place, if they've got their prototyping and they want to figure what the right GTM is to take this to the Indian market and the global market, want to figure out technological expertise, want to figure out business development expertise, and want to get mentoring in how to actually convert a product and a prototype into an actual business, connect with investors, connect with accelerators and incubators. That is the role that MAIT wants to play in this entire ecosystem. Like I said earlier, we believe we're at the cusp of a very, very interesting opportunity. All the elements, all the stars are getting aligned together, and we hope MAIT will be able to do a really successful job in championing 1,000 hardware startups out of India. Thank you.
Thank you, Mr. Murali Krishnan, for that. May I now invite Mr. Suhas Mansingh, VP Engineering Cisco, and request him to kindly deliver the industry keynote address.
Suhas, you're on mute, Suhas.
Is it better? I got two mutes there, so
Yeah, go ahead.
Can you hear me now?
We can hear you, yes.
All right. I should have known WebEx better. But anyway. All right. I was just saying this is a pretty interesting update from Deloitte on what we could do with design from India. Because if you look at the product life cycle, the place in the life cycle where the biggest brain or the biggest intelligence is needed is around design and verification. And those are the areas where India has the talent. So if you just step back and look at why we are doing this, right? Why are we talking about 1,000 startups? Why are we talking about focus on electronic design? And why should India lead it? Let's look at one thing after the other, right? So if you look at demand, right, we've got a median age of 26. We've got a lot of people interested in electronic devices. Electronics is changing things everywhere. There's a huge demand, huge local demand that exists right now, right? And if we are not able to fulfill it by producing in India, we are going to have an import bill that's going to be bigger than oil. That's going to be coming out of electronics very soon. And there's enough data that's out there to prove it. So there's a very clear, even local demand that can actually suffice the consumption of what these 1,000 startups or anything else would do. So we have that environment right there. The second thing, and I think Deloitte touched on it, was around talent landscape. We have, I myself have a team of engineers who build cutting edge products that are being deployed all around the world. If you look at Reliance Jio's network, a lot of the cell site routers or the aggregation routers were designed are completely out of India, right? So we have the talent to actually do cutting edge stuff out of India. So that other ingredient to build a product, which is a talent, and understand what it takes to build a product, although we don't have them in a huge number, it does exist, right? Now you have these ingredients, but you really need a catalyst for the reaction to happen, and for the sudden, for the outcome to come across. And that's where I think the organization like MAIT, the government, and some of the things that we're putting together is really going to make it happen. Because right now we've been, for the past 20 years, all these ingredients have been there, but we have really not achieved the outcome that we want. We're less than 1% of the patents. We're nowhere in electronic design. So I think we need to push really hard towards creating these startups. I think we have to push really hard in enabling them and giving them a leverage so that they can succeed, both with talent, with support, and whatever the government can do to make it happen, right? The other part, now you have the design, you can build the design, but it's getting manufactured outside. There are challenges with that. What do we do about that, right? So I think the time when you can lead is when a disruption is happening. If you really look at the current traditional manufacturing, for us to lead there now, I think the battle is pretty much lost, right? I think we don't have the talent base. We're not the leaders there. That was a battle that was fought maybe 20 years ago, and it's tough for us to lead on that. But fortunately or unfortunately, right, there's a disruption happening there with Industry 4.0. And what that Industry 4.0 is doing is actually making software, robotics, a lot of things that are our strength the heart of the new industry, the new manufacturing plants, right? So I think this, if you're trying to overtake a truck in front of you, waiting for a speed breaker, because that's when it's going to slow down. And that's really when you can start overtaking it, because otherwise there's no way you can really get ahead of it. I think that speed breaker comes with disruption. And I think Industry 4.0 is leading a disruption which is playing on our strengths. And if it plays on our strengths, we can actually beat them. And that could be by designing the modern factories too, right? It doesn't have to be built out here. If we can design how the modern factories work, which are IoT-based, robotics-based, and if we have the knowledge base there, it's just a matter of time before they move here. And maybe, we don't even want them to move here as long as we can design and run them completely through intelligence and robotics, right? So both things, right? Electronic design and electronic product startups. I think that's the first step that we do, where we use the existing ingredients and get to the output. But I don't think we should give up on the manufacturing and leading that through our strengths and through the disruption that's coming out in Industry 4.0, and play a role there in figuring out how we can drive maybe startups, maybe companies that can design the Industry 4.0 oriented manufacturing centers and factories, right? So with both these things, I think we have a good shot at building these companies out of India, the electronics components and products out of India. One area where I still see a big challenge is silicon. I think we have some silicon design expertise, but this is some area where a lot of investment has to be done in the universities. I think it has to be done with colleges, because the smartest kids are not getting into figuring out how to design silicon. There are two areas which is going to really drive how industries move. One is the silicon, the other is the software. Software, we have strength. I think silicon, we still need to do a lot of things. So even if we are putting stuff together like Lego, the Lego pieces, which are the silicon, is an area where we have to work with the universities and industry to build better interest, to make it sexier to do silicon. As the speaker before you mentioned, people want to build apps rather than build products. I think we really need to change this mindset of the people, and I think that this is an area where a lot more work is needed, where the initial ingredient itself is missing, I think, right? So again, I think we're in the right direction. I think we have chosen the right first step, but I think there's a second and a third step too, which is not far away from us, which can help us move further. So thank you for inviting me here, and I'm looking forward to the larger panel discussion to see what comes out of it. So thank you, guys.
Thank you, Mr. Mansingh, for sharing the industry perspective with us. I would like to now invite Dr. Sudhir Kamath, Director General, DRDO, our guest of honor, and I request him to kindly deliver his keynote address.
Thank you. Good afternoon, respected Dr. V.K. Saraswat, member Niti Aayog, other dignitaries present in this forum. I would like to bring my viewpoint for this particular subject, which we have is talking about hardware design and the startup, 1,000 startup which you want to actually launch. Now, I just want to do some brief introduction. India is a huge and one of the biggest democratic country, having around 17%, more than 17% of population. Now, when I'm talking about this, why I'm talking about this population here is that population at one point of time after independence, maybe it was a problem because of various reasons, but now I think what I'm seeing after hearing, whatever technology development is happening, this may become strength for us. Now, as you know, that after independence, India has gone through a number of revolutions, initially to start with the Green Revolution. And then after that, it has also somewhere around 80s telecom, and then IT, ICT, and then healthcare. Now IoTs and AI is now coming up. Now we are talking about hardware in this particular forum. You can see that how the industry has evolved. Initially, during 80s, I think the manufacturing industry has actually taken up, but slowly electronic industry also picked up. But then the electronic industry did not take off that well. And why is it so? But software industry, particularly the service-driven software industry, has actually taken up. Maybe that was a simpler or maybe easier way to take it forward, because here you need to have a manpower a skilled manpower and it is a soft manpower which is required. And as it is rightly been said by various people now, that when you talk about manufacturing, there are a lot of challenges involved, which I'm going to cover. Similarly, I think it is also been the technology as it is advanced. Now we are moving from manual to automatic. And as it is rightly said, Industry 4 and 4.2 actually is giving us that opportunity. Now, these things are actually also influenced by various sectors. Like one of them, of course, it is talked about the military. And other than that, other sectors like communication, transportation, agriculture, finance, power, healthcare, education, and tourism, and so on and so forth. So many sectors which is already there. And with the government of India's digital push, which has happened in all these sectors, it has become very important because in each of the sector we talk about, when you talk about military, of the software alone cannot manage. And most of our things so far has been imported. Now, if you want, unless you make it indigenous, and that is where the hardware plays an important role. And that will be very important for making Atmanirbhar Bharat and stronger Bharat. Similarly, communication is one of the key infrastructure which will actually help all the digital India schemes which the government is talking about. Whether it is agriculture side, finance side, as you know, the financial sector, how it is using the communication, power sector, healthcare also, and now present pandemic, how exactly the things scenario has changed. It's all very important to note about. And when you talk about all these sectors, the requirement of hardware will multiply manifold. As I said in the beginning, that when you are talking about India is a big country and having 17 to 18% of the world population, and we are second highest compared to China. And that is the case. And as this infrastructure is developing, hardware requirement will really exponentially grow. And this is the time when I think we should also look for not only design for the hardware design industry, which actually already, I think it has been already said, the market share of design industry was hardware design was around maybe around I think 7 billion or something like that around late 2000, and now it has I think already said that it has reached up to 30 billion. And the target of 100 billion by 2025 is well thought of, and I think it is doable, keeping in mind all this requirement which is going to come in future. But yes, there are challenges. When you talk about hardware design, is one part where we need to have a skilled manpower who is going to, whom you need to train it. Now, it is also been brought very well by Murali Krishna that I think we have a very good, I mean, lot of colleges, lot of universities teaching and giving engineering courses. But do you have a suitable course for this hardware which is focused on manufacturing or design? It is not. And how do you create it? And why all this skill, which is the talents which we are developing from the colleges, why they are getting attracted towards IT industry or a software side? The reason for that maybe they see that they have better opportunity. That is natural because as a student we see where we get more perks, and also it is an easier path because the hardware when you talk about design itself is quite knowledge driven, and that needs a skill. Apart from that, when you come to manufacturing, there are again requirement of like you need to have the proper infrastructure in place, the required equipment and facilities in place. We need to have optimized the processes to make whether it is a device manufacturing or PCB manufacturing or any hardware. And after that, the process optimization, we need to also go through the qualification process. It has been also brought out by an earlier speaker very well. Then when you talk about qualification, for military grade qualification, it is a different ball game. And for commercial qualification for various applications, whether you talk about mobility, then the qualification requirement may be different. And when you talk about agriculture, it may be different. So whatever devices or the electronic components which you are making for various applications or various sectors, it needs to be designed to meet that requirement, and it should be designed which can actually be can be optimally utilized, and it can function as it is required. Now, to do that, again, the infrastructure for qualification testing cannot be multiplied because it needs to have, I think we should have a policy where the centralized facility should be available, even if it is scattered, it can be used by all the industry. So keeping that in mind, I feel that in case you want to really go for a not only design or by manufacturing by design in India, this may be right time because various avenues are opening up. And to do that, I think there are some of the things I have some suggestions which I think we should have to attract the talent pool. We need to, I think, industry should also look into going to universities with a focused task. And I mean, whatever you have been talking about, maybe 100,000 start of what you are talking, some of them which can be probably done by the college or I mean, some of the recognized college where you feel that the skill set is there, and you should try to fund or encourage the incubating center there, and that can slowly get converted. Because once you have an incubating center funded by the industry with a some roadmap that how it will progress, there are likelihood that people will try to get attracted towards that, and then they will start to make the incubating center and can be converted later on after they come out of the college as a startup company. Now, that is one point. Secondly, of course, the infrastructure funding is also required because it's not possible for all industry to have infrastructure duplicated. Maybe we can have a pool of infrastructure distributed and it can be online available. I think for that some activity, of course, are done by Government of India. And once you have this infrastructure in place, for manufacturing, we need to have a proper process optimization. And when the processes, design and process comes, I'm sure the IP, which has been talked about, why the IP creation in India is very less, because when you go to hardcore manufacturing, it is going to add to IPs, a number of IPs may come up. But there are some challenges. When you talk about manufacturing, apart from facility and infrastructure and equipment required, we need to have the raw materials, we need to have the chemicals. Now, as of now, as you can see, the most of the raw materials, I'm not talking about strategic, but even the commercial raw materials, if you see, many of them are actually being imported. So even if you talk about fab, which I think MAIT is taken initiative for giving expression of interest to have 28 nanometer fab. And I mean, there are a number of responses are coming and it's being discussed. Even if you have a fab in place, some industry comes forward along with the government funding or whatever happens, but then how do you sustain that fab? Because a fab cannot, generally a fab is not very much profitable proposition, so no industry would like to do it unless there is a some mechanism where government supports with policy and also the support system like infrastructure, because that needs huge infrastructure, and the supporting industry also should come forward. Like if you have a fab, again we should not be struggling for chemicals, for photoresist, for so many other things like that, and even the wafers it is being imported because it is not economical to produce. So all this ecosystem need to be developed. So keeping that in mind, this I feel is major challenge because you may have all other design expertise, you may have infrastructure in place, you may have equipment, which again, most of them are imported, and it is in place. But if you do not focus on the basic requirement of raw materials, basic requirement of chemicals and things like that, process optimization is not possible. And once this process get optimized in Indian industry, then I think the expertise which has now been getting developed by the design houses, which actually supporting the OEMs outside, manufacturing industry outside, will definitely have that experience to use our PDKs or design process technologies to design our the electronic manufacturing things or electronic components or the components or processors and things like that using our PDKs, our design, and then only it will become really Atmanirbhar. So these are the some of the thoughts. And even if you suppose with government policies in place, which we need to discuss and how, I mean, deliberate probably which are the type of policies will be conducive for the industry. But after that, as I think it is rightly said by the earlier speaker, that this is the right time when there is a industry 4 coming in and there is a speed breaker. But then how do you compete with the world market? Because we are in the process of just learning and going forward. And even if we catch up with the world market, how do you compete with the veterans who are there in the market? Because when it comes to a hardcore competition, we need to actually sustain that competition in terms of pricing. So these are some of the key issues I think we need to really think over and have a thorough debate and get into it. But it is definitely, I'm sure that manufacturing industry in India need to grow, because with the present scenario, as we are becoming everything digital, the security concerns are increasing. And as you all know, the future wars are not going to be fought on the ground or in the air, but it may be on the cyberspace. And keeping that in mind, I think it's very important that our hardware, our self-design and manufacture electronic component and system subsystems are very much essential for future stronger India. Thank you very much.
Thank you, Dr. Kamath, for your noteworthy address. I would like to now invite Dr. Saraswat and Dr. Kamath to kindly release the MAIT Deloitte report in electronics, and I request other dignitaries to also join in. Can we have the virtual release, please? Thank you, esteemed dignitaries, for the virtual launch. Ladies and gentlemen, our chief guest needs no introduction. An eminent missile scientist, he spearheaded the development of the country's strategic and tactical missile systems. He is the principal architect of the Ballistic Missile Defense Program, which included major technology breakthroughs. He played a key role in developing a number of critical technologies denied to India due to the Missile Technology Control Regime. May I now invite Padma Shri, Padma Bhushan, Dr. V.K. Saraswat, Member Niti Aayog, and request him to kindly deliver his address.
Very good afternoon, and thank you for a very brief and good introduction. I'm thankful for that. I've been listening to this very interesting discussion on India becoming a major center for electronic systems design and manufacturing. It has been one subject which has been bothering me since my early days as a scientist in DRDO, because 1970s, many of you were not born at that time. When I started working on designing a control system for regulating the flow of propellant into my rocket engine, I needed an electromechanical actuator, I needed a potentiometer, I needed a device to take a feedback and run a small feedback control system to make it automated and work in a dosed quantity of propellant to go inside. I have gone through that phase. When I was looking for a potentiometer, I went to ECIL and got a potentiometer with a round head and all that. In those days, even those fine potentiometers were not there. I went around searching for an actuator, so pneumatic actuator without any electronics into it. And we had to build everything ourselves. That means we had to integrate a potentiometer, we had to put a valve to divide the flow, and then make a valve including a solenoid valve to operate not as an on-off valve but as a variety of things. So that is the kind of R&D activity which resulted into we suffered substantially. But between 17 and 80s and by the time TV systems and started coming in the country, electronics started booming. In those days, there was a major problem of import of electronics because we had to do DGTD clearance for anything import. We have to get a DGTD clearance. Import was also not feasible. So we belong to that generation of scientists and who have been able to try and develop things in the country using the best of the innovative skills what we had at that time. And that has resulted into the kind of self-reliance which has gone into today, the variety of missile systems and things like that that have happened. I still recall my journey when the first embedded computer we wanted for Prithvi missile. The 8086, 8087 was the microprocessor available in the market, and even that was denied. And the moment they came to know that we are going to use it in Prithvi, you can imagine what was the condition. So we had to stockpile and take that. But then the one thing which happened, that the scientists and designers and engineers at that point in time had the capability to design products. They could design an embedded computer using the devices and components available outside. They could write a very good potent software which will do the control of a missile and things like that. That was a capability in the engineers and designers of that time. And some of our visionary leaders like Dr. Arunachalam, Dr. Kalam, they realized that this era is going to be the era of computer science, engineering, and information technology. So there was a major push given in training and skilling large number of our own PhD scientists in different universities in the software design. And between 1984 till about 1992, 10 years, we had almost about more than 1,000 plus engineers, scientists who came out with software skills. And actually, those are the people who actually became the bedrock of India's software community, not only doing work in India, but they went outside in Germany, US, Europe, anywhere, because these were the most well-trained engineers available in software. No wonder then when the boom came for the IT, BPOs and the call centers and service of IT-enabled services, majority of these engineers, because of the high remunerations being provided by Mr. Narayana Murthy, by Mr. Wipro, Ajim Premji and others, huge amount of money. So all of them who are doing very good software work, they all got into this service-oriented software work, which resulted into the bloom of large number of these. No wonder that we did extremely well, and large number of people got trained. No wonder that today's innovation, which many of the speakers have talked about, have been working exclusively on today service-oriented innovation, which is leading to app-based innovation. In fact, when NESCOM gives me the statistics that so much of IT-enabled services are being done, so much of innovation, so many startups have happened, out of them 18 or 19 have become unicorns also. If you see, most of them, they belong to that category where service-related software activity has been done. And even in that segment, if I want to tell you software, if you look at deep engineering software, do India have we developed a CFD software upfront? Have we done a FEM software upfront? Have we developed a molecular diagnostic course? Have we developed a drug design software? Have we developed a genetic analysis software? Or even today, for example, when I'm talking of artificial intelligence or data analytics or data mining, are we in a position to say that this is a software which has been done by the Indian software engineers, where we boast so much that India has got huge software capability? So this is our problem. No wonder that we have today the entire innovation which has happened in the last 7 to 10 years, and with a lot of startups which have come. But no doubt that we have a major requirement today, and that's why when Prime Minister Honorable Modi ji talks about digital India, we have a major requirement today to go into what we call the electronic system design and manufacturing. It is one of the vital roles in the government of India's planning of things, because we are looking at 1 trillion of economic value from digital economy by about 2025. And you can say that our market size grew from about 145 billion in financial year 16 to 215 in financial year in 2019, with a CAGR of about 14%. Out of this, the import was almost 75 billion and export was only 5 billion. I think these figures may be at variance with what the gentleman from Deloitte has given, but this is the data I could get for your information. And there is a requirement that the electronic design segment is growing at about from 20%, I think that was the number, to about 27% by about 2025. So if we have to achieve that kind of an objective, we have a serious problem. For that, we should look back at what was the position of component, device, and subsystem manufacturing in the country in 70s and 80s and 90s. Before this explosion of ITs took place and before the huge import lobby came into the Indian market. I remember the transistors were being done by ECIL. I remember the potentiometers, the sensors, many of them were done by Bharat Electronics. Bharat Electronics was giving many of the devices to us at that time. And there was, even in the private sector, there were companies in Pune and all that who were manufacturing components in this country. With the onset of the import from various, I won't name the countries, various countries, we found that, and the scale at which the operations were going on in those countries, we found that the components, devices which were being manufactured in India were of no competitive nature, and as a result, and we opened up our the DGTD, which was there earlier, which was requiring import permission, that was given away. As a result, we got the market flooded with imported devices, and our component manufacturers, they became the traders in the component. Today, they are very happy trading those components, coming in truckloads or container loads of items coming from various countries and selling it in the country today. So that has become the order of the day, that thereby whatever industry existed for manufacturing component and devices in the country practically vanished. Today, if you have to get a good precision transistor register also, probably you will find it not very easy to get it from ECIL. That is the kind of situation it is. In a situation like that, if you are so much import dependent on that, then the choice becomes, do you import the component or do you import the product? And ultimately, nobody uses the component. People use the product. So what is most important today is, my laptops are coming from outside, my servers are coming from outside, my telecom equipment coming from outside, my cell phone is coming from outside once upon a time, and now we claim that we are manufacturing cell phones in the country with a value addition of maybe 15%. So in a situation like that, there is no drive for making component. And once the product is coming fully integrated, fully assembled, or it is coming in the form of breadboards or in the form of loaded boards, and you do a screwdriver kind of assembly, how do you expect that design of the product will flourish in this nation? Once upon a time, I'll give you an example. The refrigerators, what we use at home, Godrej refrigerator, the compressor of that was being done by Kirloskar or some other company. We used to manufacture compressors. But today, you name every refrigerator in this country today has got compressors coming from outside. Not only compressor, even the outer skin of the refrigerator comes from outside. Because we find that it is most cost competitive, and this whole denominator of cost which we are attaching to it is becoming one of the major problem for us. For that, Government of India said, no, in this case now we have to do something, and as a result, many measures have been taken now to make sure that the integrated systems are being now put in higher tariff, components are being released, and so little bit of inverted duty structures and things like that. I think many of you are aware of them, what Government of India is doing. I'll repeat later, but the most important part here is, if I have to do manufacturing, I have to first look at what we should manufacture. Should I manufacture components first, or should I manufacture the products first? If I have to manufacture the product, if I have the component first, who is the user of the component? I think Dr. Kamath was talking about foundry. Okay, I'll make a foundry here, completely supported by government, fully run by government. The cost of that chip is not going to be same as the cost of the chip coming from Taiwan. Will the Samsung take my chip and put it into the cell phone which is being manufactured today? Because the Samsung has already gone into a long-term agreement with particular foundry for supply of 10 million chips per year or 20 million chips per year at a particular cost. So where does that chip go? Now what do I do with that? So what is the answer? First, I should concentrate on design of products. That is one message I want to give to this forum. And I would like all the consultants who have done studies on this, we should look at how much is the import of the product, rather than saying that total electronics we are importing. Our laptops we are importing, our cell phones we are importing, all that import is what we have to look at. Now, if in today's pandemic, if we have to provide e-education, if we have to provide e-health, one of the major infrastructure requirements is that we should have tablets, the computers for the children, for the hospitals, for everything. Who is going to benefit? Lenovo, HP, this, that, and all that. Because We don't even have one company which can say that I'm manufacturing with a value addition of 60 to 70% a laptop in this country. If I can get that, at least the government purchases can be then resorted to from the Indian company. At least the government purchases. We can enable that. Even that is not happening. You take India wants to set up tomorrow about 1,000 data centers for meeting the IoT infrastructure and now what we are talking smart cities and all that. You can just imagine how many servers will be needed, how many routers will be needed, how many switches will be needed, how many devices will be needed. Don't you think it's a growing market? It's a huge domestic growing market. But there is no company which is trying to manufacture these products. I don't mind importing the chips. I don't mind importing the capacitors and resistors, but it is Indian design. It is Indian product with uniqueness in design and software and hardware. Maybe 10%, 20% costlier than the product which is available from outside. Even 30%. We have got a DIPP policy of 2017, which is giving you down, I think, 20 or 30% cost advantage or some advantage as far as the import versus business is concerned. So the focus of this particular webinar or seminar is to create capabilities to design products. And that is what will be the starting point. Once we get into the product design, we start manufacturing those products in the country using imported devices. I have no problem. Slowly then we can get into the device manufacturing inside. Now, what is the capability in these areas? I do not know, because I have not seen any academic institution designing a server. I have not seen an academic institution or a particular industry designing a desktop computer here. I remember Wipro used to design multi-bus 2 computers in 1980s and used to manufacture in a Mysore plant. They closed it down. After that, when the laptops came, nobody took the initiative. So in a situation like that, I think the answer lies in all the suggestions which have come so far are that we should develop design capability for the products, and those should be our priority. And then we should create an infrastructure for doing what we call as the component design. And that starts from the kind of suggestions which came. I would say, since the foundry is not there, and most of our, if you look at the distribution of the components, even today, microprocessor and logic devices consist of every system about 30 to 35%. Another memory devices consist about 20-25%. Then analog about 13%. So you see the distribution. I think we should get into fabless culture as much as possible. So what you gentlemen are talking of today, 1,000 startups. If I can get a fabulous design system in the country with large number of engineers who are capable, who are working for the MNCs today in Bangalore, Hyderabad, Chennai, Pune, and all those places, and Noida and Faridabad. If these gentlemen can then design for India in a fabulous way, we can enable them by creating the IMEC kind of infrastructure, by creating a centralized facilities for EDAs, electronic design automation tools, by funding the required possibility for, EDA itself. I was just taking a stock of them. It is growing from 2020, it was about 10 billion. In 2027, it is going to about 20 billion, a CAGR of 8%. That itself is a major market. So if we can create that kind of an ecosystem to support the startups in this manner, I'm sure fabulous system will come. And then we have a SCL today. At least the first cut design can be verified on a 180 nanometer system, which will give you capability for its use in IoT devices and things like that, where you don't need that kind of frequencies and scale up parameters. Yes, when we go for high-end computing and things like that, we'll go and get it done from outside foundries, no problem. So let us work in that direction. That will be the most important thing. So going from product to devices is the answer. Product design is the answer. Our focus should be on making making all the possibilities so that it will give you that kind of an ecosystem for startup. Deep engineering innovation, I think somebody touched on that. It's a very different task compared to the app kind of innovation. Deep engineering innovation needs fundamental skills, which are STEM-related skills, which are required infrastructure for testing, evaluation, and investments which are much more than what presently you are doing to support the innovation infrastructure. Where you give 50 lakhs or 1 crore to an app company, he is able to do something. If I have to do even a chip, when I was doing Shakti processor, which Kamkoti did, he funded about 12 crore rupees to him. So that is the kind of work, when we have to do this kind of work, you need that kind of monies. So the investments required for supporting the innovation in the deep engineering innovation are higher, life cycle cost is more, and second thing is market has to be there. If the market is not there, then you will have a problem. What does he do with that product? That means we have to give an end-to-end guarantee that this product, once it comes out, will go into the purchases which are for the Indian market at least, if not for the global. If the market, if the component is good, if the device is good, automatically it will fetch the attraction of the foreign community also. So we should be able to do that. The third part I would like to mention here is that the chip designers or the subsystem designers or the component designers, while the numbers which have been given to me are staggeringly high, that we in India are designing 2,000 chips per year, I am not too sure about it, but maybe I have not got the correct data. But certainly, when we went around hunting for how many people will come and design India microprocessor, we could get only a handful of people who raise their hand that they will design an India microprocessor. If we have such a tremendous capability that we can do Indian microprocessor, and why only about 10, 15, that too only professors of the age of 50, 55. I did not see any youngster coming and telling me that, yes, I am going to design your Indian microprocessor. I had Madhav Desai from IIT Bombay, Kamkoti from IIT Madras, and some people from CDEC and so on, and some guys from DRDO. You know, that is the kind of thing. I do not see any university student or any of the MNC student coming from Bangalore or something and saying that, look, I'm going to design it. You know what is the reason? The reason which I have analyzed is even the designers who are working in the MNCs do not have the complete end-to-end design capability of full system. They have only partial knowledge of what they are doing. I'll give an example of this. My dear Mohan Reddy, Dr. Mohan Reddy Saab, he is a very close friend of mine. He used to run a company called Infotech in Hyderabad. Designing, he used to call himself as aerospace designer, Infotech, aerospace systems. I thought India has got tremendous capability for aerospace system design. I was trying to get a fan for a turbojet engine. I thought, can you do the fan for me? He said, we don't design fans. I said, what do you do? He said, we analyze the design of the blade, whether it is adequate or not, based upon the software which has been given to me by GE Aerospace, and I run that and give the data to them to analyze. I'm talking of 1990s. Maybe things have changed now. I'm not, but I want to say the situation is same. So all of us on such platforms, right from the top to bottom, live in a very what is called a paradise. I don't want to use the adjective there. A paradise which is giving you an impression that we are strong, but actually our inner capabilities are very limited. We don't have the system integration capabilities. We don't have system design capabilities. As a result, we are totally dependent on things which are coming from outside. Even in the app industry, what you have done, in the app industry, we use the ERP platform coming from SAP. We use some other platform coming from somewhere. We write 2 application notes and make it compatible for a particular application, customize it to particular somebody's need by our own skills. You think that is great innovation? No. So this is the point I would like to make, that if you really want to make deep engineering innovation, let us work for product design, give a push to product design. Let us give fabulous system design. Let us set up a foundry, no doubt about it. I tend to disagree with my dear friend Kamal. If we don't set up the ecosystem, it's like a egg and the chicken story. When there's no foundry, what for photoresist? So photoresist will come if the foundry is there. The demand has to be there. So things will happen. So we should not look at economics even before we have started, working. In the morning, I gave a talk where I talked about it. We have not started walking. We are comparing ourselves on the terms of economy with the people who have already run the marathon. You can't do that. You have to talk of economics only after you raise a certain level of achievement in terms of your perfection. So we will talk about it at that stage. At this point in time, by tax incentives, by subsidies, by preferential market access, by PLI schemes, by the other possibilities, what we have already done through the MAIT initiative, government's initiative. I'm not repeating all of them because all of you are aware of them, what has been done in the last about 2-3 years. So all those schemes are basically to promote that. But I think the community now, particularly the industry, has to now take the challenge. I'm challenging that. Why is it that some of you can't now design and manufacture a server? Some of you, why can't you take up a task of designing at least a tablet or a laptop, which will be at 80% engineers, only the chips will come from outside? Why should I get the casing from outside? Why should I get this from outside, that from outside? So let us take those challenges and work in that direction. Then only the MAIT's function will be there. And last point I want to touch about the telecom, because you are also a telecom company. See, 3G, 2G, 4G, 5G. 5G was on the, we missed 2G, we missed 3G. Today, we have a couple of companies who are able to do manufacturing in the telecom sector. I know Tejas Network is there, I know VVL is there, I know a number of companies there. I know, I don't want to name all of them, but they are good companies. They have done good work. But then we have a syndrome that we don't trust our own designs. We have a problem. We are very happy that we would like to take it from outside. So when BSNL wants to now set up a 4G network in some part of the country, despite of our telling them that, look, the indigenous companies are able to provide a unified solution. May not be one company, may not have the full solution, but together they have the full solution. Why don't you give them a chance to do this 4G network in the country? But no. The BSNL will be very happy to now go and get from some foreign country, I won't name again, and on the grounds that A company has not done a work for 7,000 crores worth turnover, B has not done this kind of a work for X number of years, and they don't have experience of doing this, on all flimsy grounds, that particular indigenous companies will be left out. How do you think the industry will grow? So we are fighting now. We are fighting from NITI Aayog, trying to tell everybody, and I think government is also taking a major initiative in that, forcing people to see that the indigenous products are taken on a preferential basis. That's why the government has modified policies today. But the cultural backlash, the baggage which the companies are having is so much, particularly the PSUs, that their own R&D output they don't take. So as a result, the market is flooded with the imported ones. So we have to solve all of them, and certainly the capability has to come, no doubt about it. The market has to be made, the infrastructure has to be created, and infrastructure, I would say, MAIT kind of companies, platforms should certainly be able to provide centralized infrastructure through a holding company for testing, evaluation, standardization, and things like that. That will enable the industry to start working together for making products at a cheaper cost. That will happen. Maybe on education also, but somebody made a statement on education. But I want to tell you, the same Indian engineers are doing great job outside. So it's not the education is wrong here. It's the ecosystem to use that education is wrong here. That's important. It's not education is wrong here. The same IIT guy is sitting there in maybe in Juniper or maybe in some other company and doing, he's a CEO, somebody the CEO of Intel and Google and all that. So I don't think there's anything wrong with my education as such, but the problem is the use of that education as an ecosystem in the country. That's more important. And I think We should create that through the industrial integration for producing these things. And stop here because I can talk and talk. It is like busting out my old frustrations. But the fact remains that you are doing a great job. You should be able to certainly make some difference by these initiatives. And whatever we are able to do from Niti Aayog, I assure you that we will support all your moves for promoting manufacturing in the country in a big way. Thank you very much.
Thank you very much, Dr. Saraswat, for the guidance. Mr. Rajiv Kushu, if your audio is fine, I hope your link is fine. We request you to give your keynote address, please.
Okay.
Mr. Kushu.
It is still not good, Rajiv. You might want to just switch off your video.
The audio is... Mr. Kushu, would you like to try once again?
No.
Mr. Kushu, we can see your screen, but your audio is very choppy.
I think it's some hardware problem, not the bandwidth.
Are you using your headphone? No, switch off the headphone. Go to the computer directly.
We can't hear you still, Rajiv.
Let me check on my cell phone.
May I suggest that we could come back to Rajiv Kushu's talk later? The bandwidth is still not okay. We could proceed to the panel discussion.
Absolutely. Thank you, George. With this, ladies and gentlemen, we are now ready to commence our panel discussion. I would like to invite Mr. P.S. Easwaran, Senior Partner, Deloitte, who will moderate this session. Allow me to please welcome our panelists, Mr. Ganesh Jivani, MD, Matrix Comsec, Mr. Hari Krishnan Purvankara, Founder and CEO, Black Pepper, Mr. Bhaskar Dandapani, Director, Sales, Intel, Mr. Kishore Narang, CEO, Narnix.
Thank you, Anita. I think I don't know whether Bhaskar is here. I couldn't see everyone. Yeah. Okay. Thank you so much. So maybe I think there are 2-3 things that And Anita, can I get started, or are there introductions that we need to make? I think we have all of them. So Ganesh, thanks so much. Thank you, Hari Krishnan, Bhaskar, Kishore, thank you so much and Rajesh, thank you for your time. I think what we will focus on.
If I can just add one more, Mr. Rajesh Dhar, who is the Senior Director.
Yes, I recognize Rajesh.
HPE,
Yeah.
It's also.
Can you guys? I recognize.
Can you hear me?
Yeah, yes, Rajesh. We are able to hear you. Thanks, Rajesh. Thanks. Yeah, no, you're there. I recognized you. So thank you so much. I think great speakers ahead of before us, and I think Dr. Saraswat's points, many of them really echoing as to how the foundational elements had gone through a significant changeover. And then just prior to that, we also had Murli speaking about the 1,000 startups which create the momentum that we are looking at. And just prior to that, as Harish was mentioning before my talk about as to how we see a substantial potential, all that leading to about $100 billion a marketplace for us. So it's in that context that I wanted to seek some views on, and possibly Bhaskar, I'll take the opportunity to start with you and really understand as to how you view this. So we all spoke about digital and digitalization, and as priority themes for India's manufacturing. I think Suhas also mentioned about it. And there is significant adoption coming along, right, every year, including last year, and I'm sure the next year is going to follow. How can we really leverage these requirements to drive upstream hardware design? Or is it going to remain completely independent? Will the manufacturing remain independent of design and therefore we'll still consume products but potentially import it? So where do you see this and what do you think should be a couple of actions that we could take around that?
Yeah, I'll take a step back. Ishwar, can you hear me clearly?
Yes, you are very clear.
Okay. With technology adoption happening in pandemic and 5G is around the corner, it's estimated the 350 odd million IoT devices is going to be about 800 million in 5 years down the line. That's the amount of the edge devices we're talking about. And look at the cloud adoption. The UPI transaction is consistently hitting 2 billion. I have data for November, December. After that, I'm sure it'll be around that. And look at the cloud-bound companies, what we have. So it's all a proof of, and then from a 15th position to number 1 position, we moved in terms of consuming data in the mobile within 13 months time frame because of 1 trillion SGU, right? This is all a testament that India is actually moving towards a data-centric world. Already it started, right? So how do we ride that wave and then make the benefit of making these equipments in India is a question you're asking me, right? Right now, almost everything is getting imported, components, devices, everything. And on that very high level, what we can talk is that we have excellent companies who are doing designs, but we stop at design services because we don't find the local market. Very similar to Dr. Saraswat said, right? Who are the consumers? We are the consumers. So how do we streamline? Now we are talking about 1,000 hardware startups. How can we successfully make them from a startup design companies into a successful ODMs? That will define the success of the design and manufacturing in India. So if you don't find a path, then we will continue to be striving in the same area for some more years. I think that's a problem statement. I'm putting it very short and sweet. If you want me to dig deeper, I can go, but I'll stop here, Ishwar.
Sure. So I think it's a very relevant point, Bhaskar. And maybe on that note, possibly ask Hari about this. Given the fact that you created the organization and the ecosystem around it. Now, one of the big issues that we have been having is also the fact that the market is characterized by not just startups, but also many small and medium enterprises, many of them who are subscaled and working on discrete parts of the design value chain. So one of the issues that I generally see is that people don't have a continuum in the design value chain in India, except for some of the larger companies and potentially, those who are based outside of India in some cases. And many, therefore, would not have the ability to actually have an end-to-end view. Is there anything that we could do to create aggregation of capacities together with standards of quality that is universally acceptable and potentially even certifiable? Hari, what would be your view? And so I'm sort of taking on what Bhaskar just now said. Hari, you there?
Yeah, I'm sorry, I was on mute. Thanks for inviting me, Ishwar.
Yeah.
And the viewpoint that I'm coming is slightly different. It's based upon working in an MNC large-scale organization, stepping out to start with a viewpoint that Dr. Saraswat has mentioned. That's been the driving factor for me as a person, and it's been happening with us for some time, and especially in the hardware design space, the time it consumed for us to turn around across the 3 chains of framework, from the silicon design to system design to solution, is a massive, massive spectrum. That's what I'm going to talk about, right? I mean, I would start this conversation by saying this, just before we get into the details of the topic. We need to move into a framework of ID-led design, design-led manufacturing. That's a very important terminology. If you look at Taiwan, which has really mastered the art of manufacturing ecosystem and entire chain of ITRI through TSMCs and everybody evolving from there, MediaTek, everybody evolving from there. The country's latest theme today is ID-led design. So they don't want to call themselves anymore as a manufacturing hub. They want to call themselves as an ID design space. The reason is simple, right? If you look at ID is in your control, you design the aspect of how a product is to be viewed and used by a larger consumer, whether it is a B2B or B2C, the second stage of it, of designing aspect, naturally comes into that. When you design that aspect, what component you're going to choose from, how that's going to impact rest of the manufacturing chains, get automatically attached to that. So the whole point I'm submitting here is that, we as an ecosystem need to move into a framework of thinking of, the Maharaja Mixi versus Philips Mixi in aesthetic, who's going to buy what, right? That element of acceptability for somebody. And the idea is not only on a physical aspect, right? How the software interfaces, how the hardware portions are actually interconnected, and that goes to much, much deeper level. And I think that is the direction we as a nation need to move. We need to move to ID-led design, design-led manufacturing, part A. Part B of that is, addressing the question of what Mr. Bhaskar said, how do we create a market requirement? I think there are plenty of market requirement. Today, the definition of what we need as a product need to be completely relooked at. I'll just give 2 examples. I will consider mosquito bat, I repeated before, as the most successful product in India than iPhone, because a mosquito bat you'll find being sold on a roadside through into a marketing in a star bazaar, and everybody will have 2, one working, one not working, and that might not be a good sign, but still it's getting sold, and that probably saving a lot more lives. So if you look at how we can save, second example, right? An agricultural place where somebody comes for a mass deployment of an NPK sensor, which sits in the soil, which actually ensures what is the actual amount of fertilizer that is needed locally, and that become an integrated system, will actually save a lot of money. So the approach that is needed for us in India, it will be, of course, we need to have a sensing capability as a general framework of the product. Then computation infrastructure. Computation can be at a system level or a solution level or a hardware level, and connectivity framework. Of course, security comes interconnected to connectivity because of the development of further standards that are already happening other than the device level security. So if we identify our framework as we as a nation is going to focus on sense, compute, secure network as a framework, and we integrate IT as an overall capability, targeting very specific set of industries, right? Very specific set of industries. Now, what's going to happen once we take that call is, first ID is going to evolve. Industrial design based on specific requirements, certification process is going to evolve. In the next stage, we're going to see that we are going to use standard available chipsets. 90% of the design happening using the top 10 companies chipset that is available in the world. Next stage of that, when those companies reach a certain volume, they'll move into an associate and ASIC framework. That's naturally going to lead to a large-scale deployment requirement of localized silicon requirements. That is how the evolution phase need to happen. And take a simple example, take energy meter an example in India. Today, the Wysen stack is actually uses a $28 worth of component across 4 silicons. A company that's already doing 100 million volume today can easily switch to an NB-IoT chipset, which can be locally done. A 200 million deployment of a $1.2 chipset is more than $200 million revenue for one company. So the framework need to move into that. This is my submission on that. So our thought process has to be completely realigned in terms of which are the industries, which are the top critical factors that we're looking at. And the last addition to that, we can also look at SOM, system as a module. There are already standard chipset available. If you start giving SOM as an approach, there will be localized SOM availables, which can be modularized, integrated by larger product requirements in India. So these are the 3-4 steps we need to go in. I'm talking in much deeper scenario, completely understand that, but I think that's the purpose of this conversation, right? That we can go to the deeper level of understanding and defining what leads to what, and that's my submission here. Yeah.
Sure. I think thanks so much for the clarity. I think what I was only looking at is as to how we can accelerate that. I think one of the issues that we have been dealing with all the time, every time, is the linearity in our process. So it takes, by the time I say all and everything, it's 2013. So what I would really look for from all of you is to, and now that Dr. Saraswat and all the others are here, as to what we should do in the next 2 to 3 years, right? I think some of the revolutions that I see in manufacturing are really jumpstarting the way in which the market is looking at the portfolio definitions and the way in which they're moving. For example, large-scale electronics manufacturing is a classic case. We can argue about as to what the form and content is, but the fact is that it's suddenly creating scales of significance. So, that's one dimension that I thought, I'll also look out from all of you. We know that there are some constraints. And I think maybe, and in that, Ganesh, I'll come to you. One of the things that was spoken about by everybody, and I think as Hari spoke about it too just now, I think there is an inherent need to really start thinking about frameworks and therefore, the talent to start adapting to the new operating models. Because I think one of the fundamental concerns for talent would also be, how do you really adapt to these operating models as they evolve, and therefore, how do we really fit into the fulcrum of things which are happening? So any views as to what do we think we can do? I know we all understand there is talent out there. There are mechanisms out there to create startups, including what we are doing now. There is some schooling of talent here and some mentorship of talent. But essentially, somewhere, there is a finishing school model, and therefore the attractiveness of the industry which comes in place. And there are obviously competing industries. So how do you think we can really create the talent pool of significance, which will ensure that all what Hari said and what Bhaskar said at the start can really be accelerated in the short term? Ganesh?
Ishwarya, thank you.
Thanks.
So,
we couldn't hear you initially. Yeah, so thanks.
Yeah. So, I think our country is very large, complex, and diverse. And many times we take examples of very specific small countries, very cohesive community coming with specific cultures and all that. So, in my opinion, it would be mistake to kind of map our kind of requirements, needs, or the problems on those very small kind of countries, because they have very specialized skills. They are at a certain level and they want to prioritize because they can do everything. But for them, the need is to do actually what is more effective or efficient or what works better for them. Whereas in India, our needs actually are very diverse. We have all kinds of people, very highly talented people on the best technical institutes, engineering schools we have here. And we have also mid-range and also like not so good engineering school. Somebody talked in the beginning of this. So probably my way of actually approaching any problem, whether it's a kind of hardware design ecosystems or talent, India should actually attack multiple areas together. It would be a mistake to actually just, because I think there is this thought in our mind that, okay, list down the problems, then prioritize and attack one of them at a time and all that. So the problem with us is if we work on one, and by the time actually we are sluggish like elephant, by the time we do some progress in that, the other countries have already moved to some other place, and then we meet next time and we say that now, okay, what do we do? So again, we actually end up reprioritizing and we run from one direction to the other. In the process, really get confused. So broad-based approach, though it is not very, it's counterintuitive. It is not, but in my, the understanding is broad-based approach is necessary even in talents, because design talent also comes at various levels. So companies actually can find their own solutions coming specifically to talent. So depending on the kind of actually designing work companies are doing, they should be allowed to find their own solutions. Low-level design skills are probably easily available. Mid-level, high-level skills, actually companies need to invest in retraining and all that. But it's not very one simple problem. And sorry, but there is no one specific simple answer. And it would be wrong to really, prioritize and work only on one thing. I believe this is the wrong notion. Somehow, actually, in our discussions, we always say that, okay, what is that we need to do? Essentially, what it means is, okay, give me some quick fix, some solution, and I all of a sudden become, very strong, very powerful. Sorry, I think in our case, this is not going to work in India because the world is very fast, and let's accept we are slow. And if we keep chasing this strategy and other strategy, I think we'll always be chasing. So what we need is a very large canvas, multiple initiatives, working on products, working on silicon, working on system engineering, working on components, and we should allow people to do, because there are a lot of people here, and and people will find their space. Some people will work on components, some people work on semiconductors, some people work on products, systems, and all that. And all these actually patches will start emerging, and I think we'll get a whole picture. Ishwar, thank you.
Sure. So, I think in your view, what you're saying is that people will find their own space, and therefore it's not just one priority, but multiple priorities that we may have to deal with the way we are, right? That's essentially the view that you're coming in. Okay, Rajesh, one question to you on that note. I think being a global organization in India, and the way you've seen India's infrastructure evolve over the last many years, and I think Dr. Saraswat also mentioned about right from the 8085 processor on till now. How do you see that really leading into many of the journeys that we spoke about for hardware design? Is there a correlation between, because one of the things that we've always been unable to correlate here in these forums has been the fact that how manufacturing on one side and design on the other are really mutually inclusive, and how they are able to really drive synergies between each other. We are still treating both of them extremely differently, and still to arrive at points of collaboration or points of, I would say, integration. Where do you see that? Because, as an organization at various points, you've been on both sides of the spectrum. So how do you see this, and what do you think would be the journey for India? And in the short term, so I'm really looking at a lot of things in the next 2 to 3 years. So, not really very, very long. So again,
So, sure. Thanks for first inviting me on this very esteemed panel. And I know to Dr. Kamat's and Saraswat's comments, I worked for 2 organizations. One was with Wipro, and then I moved to Compaq, HP, and I've been with HP for now 25 years. See, my sense is, I think Dr. Kamat specifically spoke about why hardware design, is kind of coupled with manufacturing, and I'll tell you, and there are reasons, and why we should be focusing on getting some of these large ODMs into the country. There are geopolitical risks. There's a context of trusted supply chain issues. There's a disruption because of pandemic. People looking at one country and trying to see if dependence on one country for all the manufacturing, and looking at diversification of that risk. Import bill, as we get into more and more digital India, and you'll see people using more and more devices, and so these are points I think we'll have to look at. I was looking at the report, and there was a mention of Taiwan. Our own experience, we started in '89, is when we started offloading little bit of design work to companies in Taiwan, and manufacturing was happening in China. That was the entry-level desktops we started with, and that was in '89, '90, and then in '98, '99 is when more complex configurations we started offloading servers in 2005, 2006, and now 2018, 2019, more complex configurations getting designed. We still own portion of that design work within HP, but more portion of that gets done out of Taiwan. And these companies also work very closely with ODMs, because there are language issues, cultural issues. There is this whole prototyping, how quickly you can move it around. So a lot of those issues are there. So looking at what we should be doing in the country, and I've seen the PLI scheme. And there is this context of how big is the volume in the country, because unless you also have an opportunity in the country, which is big enough, many times you may not see people coming and manufacturing in India. So I would say we've seen this in automobile industry. We saw that in mobile manufacturing. If we can go selective, because you can't boil the ocean, and your resources are limited. You can't compete with some of these giants who have investments in billions of dollars. So I think look at categories and look at very granularly. Is it a desktop or is it a laptop you want to focus on? Forget about workstations. Just focus on a specific category of laptop which can provide the volumes in the country basis our usage. Look at the context. Servers today, India market is around 50,000 a quarter. Worldwide market is 2.5 million servers a quarter. Now, for anyone who has to compete and produce here in India, needs to have that volumes. So my sense is, if we go focused on the PLI, look at granular categories in short term, and my sense is the ecosystem will then build, and that will pull in more and more categories, and that's what we saw in Taiwan, because Taiwan's story is a 35-40 year, and even if we want to compress that time to, let's say, 10 years or 15 years, you can't do that in 1 year. And considering the kind of competition we have, so my thought process would be, if we want manufacturing in India, I think if we want to invite ODMs, I think we have to look at what we can prioritize, look at one subcategory which can allow us to build the volumes, and then start adding other categories, because eventually it also has to make sense to the industry. Get back to you, Ishwar.
Perfect. So it's all about, in your view, Rajesh, it's a lot to do with prioritization right now.
Absolutely.
And build the economies of scale and scope as we go by, and then take the 10-15-year view before we really hit the turf in terms of growth, and therefore becoming a very viable alternative to some of the other parts of the world. Right?
Absolutely.
Yeah. Hari, in that context, Hari, and picking up on what Rajesh said, do you see any synergy drivers? We have all spoken about the large Indian market. We spoke about Industry 4.0 being a driver. Rajesh spoke about the resilience which is required for supply chain, which is very, very significant and relevant, and therefore get the ODMs into India. Now, are you able to see patterns of growth or patterns or characteristics of the Indian hardware design value chain, if I can put it crudely, which is very similar to what has made it successful in countries like, let's say, Taiwan or other parts of the world? Are you able to see some synergies that we can take and build on, or characteristics that we can take and build on, which makes it, let's say, I would say, positive for us to embark on this journey?
Yeah, so I have actually a couple of examples on that front. I'll give you 2 examples that we have done as an example here. So we did world's first hardware piece without hypervisor for an ADAS system where we can do infotainment cluster with dual OS and real-time OS running together. It's been extremely complex hardware. We designed from the scratch, and it is potentially going to a very large OEM player. And we tried to see whether we can do that entire complex hardware design once completed, manufacture in India. We have supply chain entire system in place here now. And we realized we couldn't do that. And we had to use the system available outside to do that. And there is a lot of additional restriction with respect to specific component import and other things. I'm not coming into that logistics side of it. Second, and we managed it, that has come through. Second thing that we experienced, we got really pumped and we want to do the next thing in India. So for the refrigeration flow control system for one of the largest global players in the world, based on DNet, we want to convert their existing old legacy compressor infrastructure into an IoT-ready framework. And we did a complete gateway design through entire thing in India. And that is not extremely complex hardware. And we could do that design in India, manufacturing using the Indian ecosystem, get all components imported to India, manufacture in India during the pandemic time, exported to US. So I'm just giving you 2 contexts of how that system is actually evolving as I can see it. My 2 cents on this is actually the targeting existing manufacturing ecosystem like servers and other things, and I might be the least expert to talk about it today. But when I look for the new emerging hardware pieces, which are predominantly industry driven, which is miniaturized, which is significant hardware component with AI and other advanced components coming together, if we identify PLI, an advanced ecosystem, for example, a Dixon or a Vividian or a set of Indian manufacturing ecosystem coming together hand in hand, because they've already figured out today those companies are actually, Dixon is manufacturing for very large players in the world. and they have entire component supplies already in place. So if you identify an ecosystem where design elements in India can be integrated with the Indian evolving PLI linked OEM infrastructure, then I can definitely see that challenging on a global scale. Of course, it might need initial incentivization. I think that should be the right model for us to approach to tackle it today.
I think picking from what Rajesh said, I think, getting the ODMs is one, and the second one is really ensuring that, the likes of these large manufacturers, they are obviously getting integrated at the back end so that, you create that economy of scale in a rapid manner, and they become globally competitive because they're anyway supplying to global majors. I think that's the point that I think you're looking at. Bhaskar, on that note, we spoke about people, we spoke about the dimensions around ODMs. We spoke about really the characteristics of enterprises, etc. But one of the things that we generally are a little bit away is IP. And while we talk about generation of IP in India, do you think that is a very critical factor for companies to set up design houses in India, be it Indian companies, or because we also hear about design houses which are in other parts of the world for Indian entities, etc. So where do you see that? Do you see IP as a big enabler to this entire driver? We spoke about design and manufacturing, but there is in the middle of the whole piece, there is IP.
Yeah, true. If you look at closely IP filing, I think one of the data points which we saw, I think in your presentation, is less than 1% filing happening in India, right? I think that's very tightly coupled to where the investment is coming from, and then also where the manufacturing is going to go. The investors basically wanting to have the control of where they want to manufacture. In our case, yeah, the answer to your question is yes, that plays a critical role. And Hari also alluded to the ID based design and then manufacturing based on the ID, right? So it has a very tightly coupled. So I'm also that much knowledgeable on the IP side of it. Answer to the question is yes, it plays a major role, but I think I can throw it back to Hari because he's into the thick of designs and IP development. So I think it's appropriate for him to comment something here. I'm sorry.
Sure. Quick words, Hari, before I go to Kishore for a couple of questions to him. Any quick words on that?
Bhaskar, I certainly are definitely qualified to talk deeply about it. But as you asked me to put 2 cents on it, I completely believe that the IP creation framework, if you look at it, right, I've actually submitted a proposal as part of the Semiconductor National Task, which has been part of on how do we create an IP framework in India, and that has been submitted to MAIT some times back. So I've been asked to do a case study on ITRI, IMEC, Singapore Innovation Ecosystems, and Israel Innovation Ecosystem, which is the most hot bed right now in terms of what is really happening out there. One common element that has been observed was that there has been a consolidated approach for creating IP where 2 parts of it. One is the industry academia partnership and creating a center of excellence specific to that under that ITRI or whoever came into picture was very much important. And that's been driven as a standard project where the participation of doctoral students, participation of key architect experts from the industry, a kind of group has formed to ensure that there is a mission to drive that. And I do not find that kind of element happening right now. A simple example is if you take 5G base station standards to be designed and developed and standardized in India yet, we really don't know where it's standing today. India specific 5G base station standards, if you are really looking at it. That is one typical example if you want to look at it. Now, second challenge that we are finding today is that there are absolutely phenomenal talents available in the MNC infrastructure in India. But they're pretty much part of a larger global ecosystem where they're driven by a different level of economic agenda in those MNCs. Now, those level of talents with that level of expertise and with that level of cost being made available in an evolving startup ecosystem is not going to happen unless and until either the government funds that infrastructure that the way it happened in Israel, or you find large-scale investment happening, angel and the round of investment happening in the startup ecosystem and the hardware design in India. And I don't find both of those opportunities not really emerging at this point in time. So today, IP development is either driven by a group of academic-based research and moving forward, or driven by crazy nuts like us who comes out of the comfort zone and start going in and balancing the economics of the development and identifying a product requirement is the gap. And in all my conversation, I've seen people are still struggling. Beyond any doubt, IP development is an extremely key component. But we need to choose what are those IPs we're going to develop. We should not reinvent the wheel. We should not go for a DDR-X to compete with another supplier in the world. We should go for next generation IPs, which has definitely future value, predominantly in Indian context of application itself. And that will have unique advantage to start with, because this is where everybody want to sell anyway, right? And that's my contribution on that, Bhaskarji, if I put my thought in that way, yeah. Yeah.
Thanks, Eddie. I know you from my free scale days, so I knew you're a better person than me to answer this question.
Well, I don't think so. Thank you, but yeah.
Is Ishwar there, or I think maybe he's got disconnected?
I think so. It's showing a indication.
I think he has a bandwidth problem.
We will just check with him one moment. I think he's facing a bit of a challenge. Maybe we could continue with the panel discussion the moment he joins back. In the meantime, Mr. Kushu, I hope you have reconnected your audio.
Yeah, can you hear me? Is it better?
Loud and clear, sir. Loud and clear. Thank you very much. I'd now like to invite you, Mr. Rajesh Kushu, Chairman of the Board, IESA, to share your views.
So should I? Okay, so it's already there.
Yes.
Should I share somebody's sharing it for me, right?
That's right, sir. You can just say, please move on, and we'll take
Okay, thank you very much. Sorry for the trouble. I'm still not clear why all this happened. But anyway, I think let's move on. So I'll try to cover it as quickly as possible. But I can assure you, I did not prepare this presentation in the last 15 minutes. So this was done a few days back. So move to the next for the agenda, because you'll see a lot of the stuff which all of us start kind of getting summarized in the presentation. So I'll try to cover the following things like electronics market in India, consumption versus production, growth strategies with respect to design, products, and manufacturing, and some of the key recommendations. I think we did this, I think this was done almost 5 to 6 months back, and I just modified some of these. And let's go to the next slide, please. Please stop me whenever you feel like asking any questions. I will try to answer to the best of my knowledge. So coming to the electronics market, you see it's basically a sunshine sector for India. So we grew from 2016 to 2019 at the rate of 14% CAGR. And we're expected to grow at 16.6% between 2019 to 25. And let me tell you, this was done before the impact of PLI. So we expect a couple of percentage points going up, and we are already seeing, for example, many of our members who are selling components in the country, the growth this year has been phenomenal. Although it is a global phenomenon, but then it is basically true that the ESDM market at the consumption level of semiconductors is growing, and that is a positive sign. I'm sure if Mr. Saraswat is listening to it, he will be really happy to hear that. See, coming to the total, basically how India is moving. So we will definitely go into the top 3 countries in ESDM consumption, as well as coming to the in terms of production, we will be among the top 5 countries in electronics production by 2025. When it comes to the GDP contribution, so GDP contribution when it comes to the ESDM space is at a very low base. Now it is 3.4%, which is roughly $101 billion. And with the kind of projections what we are seeing, it will go to 6.4% by 2025. And the best part about the whole thing is that it will generate an employment of close to 10 million people in the country, both direct as well as indirect employment. So can you go to the next slide, please? So coming to the domestic production, I think you can see domestic production. If you see the graph on the left-hand side, if you see it grew to $81 billion from $48 billion in 2016, which is a CAGR of close to 19.1%. So, and it is expected to grow to $260 billion by 2025, which is again growing at a rate of 21.5%. And what it means is from the reduced imports from 57 to 49% from 2016 to 2019. So overall saving of close to $15 billion. And the way we are going, we'll expect it to go down to 29%. So from 49% to 29%, which means a saving of close to $66 billion. So you can see substantial saving happening. So, but one thing very important is, I think many of you already touched upon it, is domestic value addition is still in low teens. It is roughly around 17%. We need to definitely and target as a country to go to 40% by 2025. And what does that mean? It means a value creation of close to $60 billion in 2025. And I think there's a distinct possibility, and there's a possibility of going, and we have seen a lot of the incentives going in that direction. Next slide, please. So again, coming to the electronics market, if you see how the whole of this market is divided, we have low value market, which is the majority portion of the whole on the 2016, if you see on the left hand side. 44 billion is low value market. Only $4 billion is the high value addition of market. And when it comes to the electronic design, what we do in 2016, the number is $13 billion. But if you see all these three elements, which are very, very important, nothing is at the cost of other. See, 44 will go to $73.7 billion. And this $4 billion high value addition will go to 7.3. And if you see 2025, with all the incentives which are going, the low value addition will go to $237 billion. A lot of it will be exported. But still, we will see the high value addition not growing substantially, but then still from the number point of view, 7.3 to $23 billion. What is really encouraging is the design of products which is happening in the country, that will grow to $60 billion. So from $20 billion to $60 billion in 2025. So all these three are very, very encouraging, and I see a very bright future for the ESDM space in the country. Next slide, please. Okay, so as I said, the design is a key element, and most of the companies, including ourselves, I come from Texas Instruments. We were the first company to set up the design and R&D center way back in 1985, which is much before when the India opened up, much before 1990 when the globalization in India happened. And we have reaped all the benefits, and we have seen how the products are being designed. Today, not even a single product which TI manufactures and designs, not even a single product is not being touched in the country. That means every product is being touched in the country. And many of the products are basically from the inception all the way up to the RTM. Only manufacturing does not happen in the country. So I think we have made a lot of progress in the last 35 years. And this is, and I kind of agree to a certain extent with Dr. Sarsat, but then there are definitely some green shoots which are appearing, whereby many companies, and I can tell you, TI is not the only company which is completely designing products right from scratch up to the RTM. But there are many companies like us who are doing that that way, and there are many product companies who are doing a similar thing in India right from the scratch doing the complete products. But I do agree with Dr. Saral's statement is that we tend to believe more on the products which are probably imported. That's probably still the mindset, and it needs to change, and it needs to change from the government itself. I heard him loud and clear that even BSNL still prefers products being designed by our by many of the countries which he didn't name, but the many of the countries who are big in manufacturing. But we tend to not give preference to the products which are being designed in India and designed by Indians. And many of these products which basically get imported into India are being designed probably by many Indians outside of India. So I think it needs slight mindset change. And I'm seeing, as Dr. Sarsat mentioned, there are a lot of initiatives being done from the Niti Aayog level where the products which are being designed and manufactured in the country will get some kind of a preference. Although I'm sure things are going in the right direction. I think we need to be competitive, but I think that's the right way to do. Can we go to the next step? Next slide, please. So coming to this high value addition domestic products. So see, only 9%, as per the data what we have done along with F&S, 9% of the products are high value addition. So products which have domestic value addition of greater than 60% in 2016 was only $4 billion. And in 2019, it went up to $7 billion and is expected to go to $23 billion. There's still a huge gap, while as the low value addition is almost touching $230 billion, while as the high value addition is still $23 billion. So what do we need to do? So we need to basically, need to innovate. Innovation-led design is critical. Design-led manufacturing is critical. Design, innovation, IP will help create high value add products. And products on new use cases, for example, medical, which is, and because of the pandemic, there are many cases. For example, we are today struggling with the oxygen cylinders, while as there are many solutions where you can basically generate oxygen using the ambient atmospheric air available or the water available, but most of these equipments are today imported. Can't we do it before? Should we have done it before? Probably a year back, the way we worked on the ventilators in the last 18 months, and from being a very minuscule producer of ventilators, we were one of the largest producers of ventilators in the world. Can we do it for the oxygen generation, home appliances perspective? Yes, we can do it. And what stops us from doing it? I think we need to really, industry needs to come together and probably work in that area. And IESA, we recently started an act. We have started working on it from the basic steps. We have collected some of the Indian manufacturers who are in that area, and how can we help them as an industry to build products and come up with some solutions so that we can design as well as manufacture in the country. So coming to what IESA sees as an organization, what do we need to do? So you must have heard about this 1K, 10K, 100K, and 1000K initiative of IESA. 1K, basically 1K startups, 10K IP creation, and 1000 and 100K crore of business value. And as a result, have 1000K job creation, which is both direct and indirect. And one thing very critical, we want to target 1000 startups, and in that 100 fabulous startups are being set as a goal for the country. And we did a project along with the government of Karnataka called SAFAL, which is called Semiconductor Fabless Accelerator, where the government of Karnataka together with IESA came up with a facility in Bangalore where many startups in the semiconductor product domain are incubated, and many of them are doing really innovative products in that area. And what we are trying to do, we are working with Ministry of Electronics and Information Technology to take this fabulous initiative and not restrict it to Bangalore, but take it to pan-India. And we are at a good stage. And I think what I understand is it's at a stage of getting approval, and we can see if that happens, I think that will probably lead to a fabulous revolution in the country. And if that happens, that will basically address the main issue of IP creation and creation of semiconductor products in the country. Last but not the least is we are also targeting the 900 electronic product companies in the country. And some of the initiatives, I don't know, many of you may not be knowing, there's an initiative called Electropreneur Park, which IESA together together with Ministry of Electronics and Information Technology and STPI, came up with these electropreneur parks. One is in one is in Delhi in the university campus in the South University, and the another which came up almost 8 to 9 months back in Bhubaneswar, along with STPI. And we are playing a critical role in helping these startups to come up with products. And many of these companies who are getting incubated in these EP Delhi or EP Bhubaneswar are having products in different areas, whether it is medical applications, whether it is EV, electric vehicle, and automotive electronics, and really differentiated products, not only aimed for India, but for global requirements. I think I touched on the expanding SAFL into different areas. So what I say, the impact of 50% increase in high value add products by 2025 will basically help a country in basically going to the next level of design and development products in the country. Can you go to the next slide, please? Yeah. So as I said, increased value addition in LVM, which is low value products. Current value addition is close to 17% in domestic production, which includes activities like assembly testing, PCB manufacturing, and PCB assembly, PCBA. So strategies are make recently announced PLI schemes based on the value addition. I think I heard some of it being talked about by my colleague from Deloitte. I think it really makes a lot of sense if we make it PLI schemes based on the value addition which is being created in the country. And the second thing, what we are trying to suggest is incentivize setting up ATMP, display fab, display module manufacturing, LED manufacturing, power electronics fab. We call it a gallium arsenide fab. And also we are kind of, that's the other strategies which we are talking about is debt venture fund for working capital, interest relief of 3% on financial cost. And what it will do is basically 60 billion addition value created by moving from 17% to 40%. Build-up of components, ecosystem, and supply chain is another important thing. And I think one of the important things which we are seeing, and we are working, many of our members are working on, is basically we are seeing a lot of raw materials which today go into pharmaceutical companies, which go into paint industry. If we work on it, we can actually get a lot of raw materials for the semiconductor fab as well. Of course, the quality requirements are completely different. They are much higher. But then having said that, it is possible to do it if we have a market, for it. So coming to my last slide, which is the key recommendations. My recommendations is basically on part of IESA. I'm trying to tell you is that incentivize training, internship, IP creation for design companies, create $1 billion fund for what I said, 1K, 10K, 100K startup program, geographic inclusion of all states and union territories for the innovation electronics, incentivize setting up ATMP, which is assembly test, which is the next step after fab, display LED, power electronics fab for high value addition, make PLI incentives linked to value add percentage, encourage manufacturers with high value add, probably have a cascading incentives, debt ventures fund, and interest relief for working capitals and investments in manufacturing, National Electronics Commission on the lines of ISRO, National Institute of Semiconductor and Electronics Research, NISER, on the lines of IMEC in Belgium. So I think these are some of the recommendations which we have given to the Ministry of Electronics and Information Technology almost 6 to 8 months back, and I'm really happy many of these have been already put into action, and there's a task force for many of them, and we will see many of the announcements in next 6 to 8 months in various areas which I talked about. Thank you very much, and if you have any questions, please feel free to ask. I try to be as brief as possible. Thank you very much.
Anita, are you there? Thank you very much, Mr. Kushu. It was really an insightful presentation. I see Mr. Ishwaran is back. Mr. Ishwaran, yes.
Am I audible,
Please carry
Anita?
on with the discussion.
Am I audible, Anita?
Ishwaran, you are audible.
Okay.
Yes, you are.
So
Yes.
thanks so much. I just thought I will wind up our panel discussion. I think we spoke about a few things, but I had a couple of questions for Kishore, which I thought I will use for us to get to the final areas. Kishore, we have, I think, covered a large spectrum of the set of aspects that we would want to do. What we did not cover is potentially the ask from the government, and a few things that all of us would have as aspirations. That while we spoke about incentives, and I think Rajiv also touched upon the incentive part just now, as well as the electronics commissions, etc. But if there were three asks that you think we should have for India to realize the vision for 100 billion, 100 billion is a number, 100 billion hardware design hub, what would be the three asks that you would think interventions from the government would be required?
Okay, very interesting question, and I think it's this subject is very close to my heart since I've been only into design for last more than 4 decades, and I have no other commercial activity that everybody knows in the ecosystem. So I think before we talk about the ask from the government, let us see where do we stand. I think everybody talked about a lot of things, but one thing was conspicuous by its absence was innovation. Okay, see, where is the innovation ecosystem? When you talk about design or even manufacturing, everybody has accepted that we need intensive design capabilities. But even for design capabilities, how does it come? Innovation ecosystem, design ecosystem is not there. And I think I've been talking about this point for last more than a decade when there was some kind of innovation council sector or regional and all those things. And I used to say, before we talk about innovation or design, let us try to see where is the competence. We have in last couple of decades we have lost competence to design in our engineers. They all become clerks, software, IT guys. So unless we invest some time in building the competence to innovate and design, we cannot expect anything to happen in spite of whatever government may also try. So government also needs to, so coming back to your question, so I think most of my personal anguish has been already shared by Dr. Saraswat. So he's taken my speaking point, so I don't need to repeat any of those things. So I'm really happy he talked about what we have been through in last 4 or 5 decades, the kind of engineering temperament we had, the design temperament competence we had, and where it has gone because of everything is focused on money and quick turnaround and all that. Now, the three asks, if I say, first thing is, when we talk about competence to design, how does government help in this? I think we need to. I think there is a discussion for last 3 or 4 years in MAIT, but I think it has not taken off in a proper way. Maybe it is. But I was told in the last couple of months that the file has been dusted. Now it is again revived. But what we need is a National Institute of Design and Innovation in Electronics. And this is the term which is not my own, coined by MAIT only. This term was coined by this thing. And what it has to be. It doesn't have to be another IIT or triple IT or NIT or any of those kind. It has to be on the lines of NID and NIFT, like, where the faculty is from the industry. People teach, people who have been into design, they teach how to design. People who have not done design, how do you expect the academicians to teach design who have never done any design? And anybody who has not done a software development can only talk about theoretical, logical algorithms and approaches. They cannot tell us how do you debug a code when you get stuck. How do you handle the Stack Overflow? How do you make sure that you don't get into kitchen sink effect? How do you handle the EMI, EMC problem? How do you handle the surges problem in those designs? So we need those kind of hands-on people to teach our young engineers, whether it is after graduation or even within the graduation stage. Okay, that what kind of skill set that we need to make them a good design engineers. And when we talk about competence or temperament to engineers, I have no doubt we have still ample motivated people. What is missing? We do not have mentors, senior design people who will handhold and guide and groom those young breed. I see most of the time the R&D managers or team leaders in most of the companies and manufacturing companies, they simply get an assignment and they pass it on to the young guys, and they are expected to do it from those Google's Stack Overflow, GitHub and all those things, and some reference design from silicon vendors. if it works, it's passed on to the management. It doesn't. So that is one of the things that is design. Another thing is when we talk about, okay, now I have been running a design house, small independent design house for last 4 decades. When we say how do we move from the manufacturing to design, we already know we have 250 plus or something like that mobile manufacturing unit, but everybody knows there's screwdriver assembly. So there's hardly any value addition, 10 to 15% has been already acknowledged. So how do we now have, if we really want this ecosystem value addition to be in India, we need some design houses who will do end-to-end design of mobiles and all those smart, whether those cameras and all those smart TVs and all those high-end multimedia products, the ICT products. And if I want, I had a chat with some people about 6 months or a year back. I want to set up a design house. I talked to Qualcomm and MediaTek. You know what I was told? Oh, you will have to pay about $1 million for the first license even for the kit, SDK. How I'm going to set up a design house for mobile, this thing, and I have to first shell out $1 million. How do I do that? This is a simply way to say, okay, go get lost. You simply go back to China and Taiwan for all the design support. So I think this is one of the points where maybe government could intervene. Okay, maybe government could say, okay, we buy this all IP or license part of this thing and give it to anybody who is willing to design. And whenever we talk to even any silicon company for any disruptive product, we are given a very interesting, very diplomatic pushback. No, you don't have scale. How can we support you on the design on this? You'll have to. Why don't you work with those Advantech, Lanner, and all those ODM people? We as design houses are pushed to talk to them. Is this the kind of environment ecosystem that will enable or is conducive for design innovation? So that is where startups are pushed back whenever they think about. I do not blame them. I may have grudge, but I don't blame them because I know their limitations. Whenever they try, and a lot of people come to me, they are constrained to actually grow. And even these incubation units and all these, whether it is from NASCOM or anywhere, everybody talks about mentorship, and we have a lot of industry mentors. But what are those mentors for? And what the startups are looking for mentors who will help them scale up, who will get them VCs, who will get them there. Nobody's looking at mentorship in ruggedizing their product, getting them hardcore design competence, building their design competence to such a level that they can have end-to-end global market ready product design, which is compliant to all the global standards. So these are some of the very quick things, and maybe there. I think I can go on and on. If you have time,
perfect. No, but I think very relevant, and I think all what you said, starting from innovation to really experience in the academia to what you said on ground experience for people to become globally competitive. I think very relevant point. So Anita, thanks for inviting me to be the moderator of this very esteemed panel. I think we had some fantastic views. I think what stood out for me was not just the fundamental divergence of views, but I think more important also the way in which we are now able to look at the aspects that need consideration. I think there is a big dimension around prioritization that we spoke about. There is an angle around talent that we looked at. There is an angle around innovation that we spoke about. And also, the need to invite ODMs to be in India as we start looking at, generating our own big unicorns in electronic hardware design. So, thank you, everybody. Thanks to my fellow panelists, all esteemed guests here. And thank you so much for your time. And it's a pleasure for me to be here as part of this gathering. So thank you so much.
Thank you. Thanks, Ishwar. Thanks.
Thank you. I thank you all panelists for such great perspectives. I would now like to invite Mr. Ambrish Bakaya, Senior Director Corporate Affairs, Asia Pacific and Japan, Hewlett Packard Enterprise, and he's also the chairman of the MAIT Finance Committee. Thank you so much, Mr. Bakaya.
Thanks a lot, Anita. I hope I can be heard.
Yes, loud and clear.
Yeah, when I was requested to give the vote of thanks, I sort of looked at the details of this session, as part of our Electronics and Telecom Manufacturing Summit, and it's really like a double-barreled shotgun, which we have gone through. Really two very exciting and related sort of phases. One, of course, a very detailed discussion on how do we make India as a global center for electronics, hardware, system design, and I think a lot of discussion around that. And then, what Murli and the rest of the MAIT team has worked on is the launch of MAIT's creating 1,000 electronic hardware startups. So two really very, very powerful sort of sessions which kickstarted the second day of this very interesting summit. A little different from typical PLI-led manufacturing summit. So I think really, great credit to the MAIT team. But first of all, I'd really like to thank, the strong participation which we had from the government here with Dr. Saraswat, Padma Bhushan, Padma Shri, and member of Niti Aayog. I think his views, as always, very passionate, very strong, a picture of how Niti Aayog, and he sort of sees this larger space. I'd also like to thank Dr. Sudhir Kamath, who's the DG for the DRDO. Again, I don't know if he's here still, but I saw that he sat through most of the, all the sessions. And I think, again, a very strong sort of pathway about how the evolution has sort of taken place, his sort of perspectives on the design space, as well as, how the hardware sort of ecosystem can be sort of set up. So I think really, really very, very sort of insightful. It would be, again, remiss for me to not thank a couple of more, government people who I saw. I saw, Mr. Saurabh Gaur. He sort of had also shown up and listened, and also I think Dr. Ajay Kumar Garg, because these are the people from the government who actually make a difference, and are when they listen to what we are talking about in the industry. So after the loud thank out to all the government speakers, and Anita, please correct me if I miss somebody there, but again, Mr. Ishwaran, I think it's really great to see the amount of work which Deloitte has done, and the immense amount of knowledge, and those 8 or 9 points which you talked about, and the great focus which you have said on strategic segments, shared infrastructure, and the enabling ecosystem. In fact, the enabling ecosystem thing came through pretty strongly in a lot of the other sessions also, whether it was Dr. Saraswat or whether it was Dr. Kamath. Murli, and I think again he's not there. I was part of the initial discussions when we talked about this 1,000 hardware startups, and really great work done by the team there. And I know in HPE we have a Catalyst program, but there is again this larger opportunity to work on the hardware sort of space. Great work. Thank you, Murli, for all the efforts that you have done. I think Suhas has also left, but I think the perspective from him about how a large sort of global R&D company, a global company like Cisco looks at this space was really insightful. I think both Dr. Kamath and Dr. Saraswat's sort of keynotes were really insightful. And whether it's design for product, whether it's creating the infra for components, whether it's looking at the fabless culture. So all of this, I think, really provided the feedback which helped Ishwaran and the rest of the panel. It would again very interesting panel with the depth from people looking at design all the way up to global sort of companies. So thanks a lot, Kishore. Thank you very much, Hari. Thanks, Ganesh, as well as Bhaskar, for the really, the really varied and passionate discussion that we had. Unfortunately, it got interrupted, but I think that gave us, and it's giving me the opportunity to thank Rajiv also for a very insightful sort of presentation. What was interesting is that, Frost & Sullivan is talking about $60 billion, and I think the leap of faith which Deloitte is talking about as being possible to a $100 billion industry is really, something very, very aspirational. I think Rajiv's being here was also indicative of the work that MAIT is doing with other associations, and whether it was with Alcina yesterday, and a shout out that IESA and MAIT are together going to work on a design Section 8 company which we are setting up. So, it's not just a one-off thing, but stands for a great sort of relationship which MAIT is also building up with other associations. So thank you, Rajiv. I know we have a couple of more sessions, including supply chain and MSME and how that would tie up. So if you all can stay back later and join some of those, that would be really sort of great and useful. Harish, Anita, and I don't know if George is there, but thank you very much. And back to you, Anita, and really thanks to everybody for being part of this.
Thanks,
Thank you
Amrish.
very much, Mr. Gupta. Thank you. Thank you. We'll close the session now. Thank you very much.
Thank you.
Thank you.
Bye-bye.
Thank you.